So let's do the integral of 1 over the cube root of x plus 1. The integrand is not a rational function, so what we can do is apply a rationalizing substitution to make this a rational function, which is easier to work with. A rational function, by the way, is a function that's in the form of a fraction where both the numerator and denominator are polynomials. So to do this, we can start by substituting u equals the cube root of x plus 1, and this is the same as x to the 1 over 3 plus 1, and this means du equals 1 over 3 times x to the negative 2 over 3 dx. Since when we differentiate x to the 1 over 3 plus 1, the constant term of 1 disappears, and for the x to the 1 over 3 term, we need to bring the 1 over 3 to the front as a constant multiple, and reduce the exponent of 1 over 3 by 1, so the 1 over 3 exponent becomes negative 2 over 3. To find an expression for dx entirely in terms of u, we need to first multiply both sides of this equation by 3x to the 2 over 3. So if we do that, we end up with dx equals 3x to the 2 over 3 du. And if we want to rewrite the x to the 2 over 3 in terms of u, we just need to look at the relation u equals x to the 1 over 3 plus 1. If we subtract both sides of this relation by 1, we get x to the 1 over 3 equals u minus 1, and if we square both sides, we get x to the 2 over 3 equals u minus 1 all squared. So now we can rewrite 3x to the 2 over 3 du as 3 times u minus 1 all squared du, since instead of x to the 2 over 3, we replace that with u minus 1 all squared. If we substitute this into the expression, the 1 over cube root of x plus 1 becomes 1 over u, since we let u equal cube root of x plus 1, and then this is multiplied by 3 times u minus 1 all squared du, since dx equals 3 times u minus 1 all squared du. So this just becomes the integral of 1 over u times 3 times u minus 1 all squared du. If we put all of this into a single fraction, this becomes the integral of 3 times u minus 1 all squared over u du, and once we expand the u minus 1 all squared, this becomes 3 times parentheses u squared minus 2u plus 1 all divided by u du, and then if we expand the expression, the numerator just becomes 3u squared minus 6u plus 3, and the denominator is still u. If we distribute the division, this becomes the integral of 3u minus 6 plus 3 over u du. If we integrate each term separately, the integral of 3u is 3 over 2 u squared. The integral of negative 6 is negative 6u, and the integral of 3 over u is 3 ln of the absolute value of u, and we have to add the constant of integration c. Since we originally substituted u equals cube root of x plus 1, if we substitute that back into the expression, we end up with 3 over 2 times cube root of x plus 1 all squared minus 6 times parentheses cube root of x plus 1 plus 3 ln of the absolute value of the cube root of x plus 1 plus c. If we do some more algebra, the expression becomes like this, where if we expand the cube root of x plus 1 all squared, we get x to the 2 over 3 plus 2 cube root of x plus 1, and if we distribute negative 6 times parentheses cube root of x plus 1, we get negative 6 times cube root of x minus 6, and the rest of the expression stays the same. If we distribute 3 over 2 times x to the 2 over 3 plus 2 cube root of x plus 1, we end up with 3 over 2 x to the 2 over 3 plus 3 cube root of x plus 3 over 2, and the rest of the expression stays the same. This is equal to 3 over 2 x to the 2 over 3, and if we combine like terms, 3 cube root of x minus 6 cube root of x is equal to negative 3 cube root of x, and we also have to add the 3 ln of the absolute value of the cube root of x plus 1. And we also have to add the constant of integration c. I omitted the constant terms because that's covered by the constant of integration c. So technically the c in the final expression is not the same as the c in the previous expressions, but I'm not going to worry about that. And let's just say we add some arbitrary constant of integration c. So the integral of 1 over the cube root of x plus 1 is 3 over 2 x to the 2 over 3 minus 3 cube root of x plus 3 ln of the absolute value of the cube root of x plus 1 plus c.